Okay, this video is all about resistors when they are in series. When we have resistors one after another in series, they're going to increase the overall resistance. So to find the total or equivalent resistance, we just add up the individual resistors. A bunch of resistors in series is like having a longer resistor, and a longer resistor is going to be harder to push current through. So series resistors are definitely going to increase resistance, decrease current. So let's go to a few practice problems using resistors in series. Let's start with this one over here. Find the equivalent resistance of the circuit. Now this is a series circuit. We have one resistor, then R2, and then R3, and there's our battery. R1 is 15 ohms, R2 is 22.5 ohms, and R3 is 5.0 times 10 to the 2 ohms. So to find our equivalent resistance, our equivalent or our total, we're just going to add up R1 plus R2 plus R3. That's going to give us a total resistance of 15 ohms plus 22.5 ohms plus 5 times 10 to the 2. That is going to be 500 ohms. That gives us an equivalent resistance of 537.5 ohms, or to 2 sig figs, our equivalent resistance is 540 ohms if we round correctly. That's all. Just add up all the individual resistances. Let's go to something a little bit more interesting, but not too much. Find the resistance of R2 if the equivalent resistance of the circuit is 155 mega ohms. Now here we have another series circuit with 1, 2, 3 resistors in series. We are given R1, we are given R3, we don't know R2, that's what we want to find, but we know the equivalent resistance. We're still going to use the same old equivalent resistance equation. R total, or R equivalent, is equal to R1 plus R2 plus R3. So if we want to solve for R2, we're going to have to subtract R1 and R3 off from both sides, and we end up with R2 is equal to R equivalent minus R1 minus R3. So that's going to give us R equivalent is 155 mega ohms. So this is going to be 155 times 10 to the 6 ohms minus R1, which is 1.6 times 10 to the 6 ohms, minus R3, which is 8.5 times 10 to the 7, 8.5 times 10 to the 7 ohms. Now, what I'm going to do is I realize that mega means 10 to the 6. It means a million. So I'm going to rewrite everything in terms of mega ohms. I could plug it in a calculator like this, but I think it's easier if the units are all the same. So this is 155 mega ohms minus 1.6 mega ohms minus 8.5 times 10 to the 7. That's going to be minus 85 mega ohms. And that's going to give us an overall R2 value of, after plugging that into the calculator, I'm going to get 68.4 mega ohms. However, when we were subtracting here, this was only precise to the nearest 1 mega ohm. So our sig fig, we should round to the nearest 1 mega ohm. Our final answer should be R2 is equal to 68 mega ohms. Pretty straightforward. Just subtract instead of add. Let's look at one more. It's a little bit more interesting. Here we need to find the EMF of the battery. This is new. And we're shown this circuit. It has two resistors in series. One is 32 kilo ohms, one is 12 kilo ohms, and it also gives us the fact that there's a current running up at 56 milliamps. So I'm going to label the EMF with a little epsilon. Actually, I'm going to call it EMF. EMF. That's the voltage on our battery, if you remember. And so the voltage on our battery is also going to be the same as the total voltage of the whole circuit. So we're eventually going to have to find the total voltage on the circuit. So we're actually going to have to use two equations here. So in my equation zone, we're going to use Ohm's law, and we're also going to use the equivalent resistance equation. R equivalent is equal to R1 plus R2. But let's list my givens. We know R1, and I can choose anything to be R1. I'm going to choose the top resistor is equal to 32 kilo ohms. R2 is the bottom resistor. That's equal to 12 kilo ohms. And we also know the current, I, is equal to 56 milliamps. Make sure that's a capital I. Our unknown is then going to be, well, our final unknown is the EMF. We could call it EMF. We could also call it just V total. But there's an intermediate unknown we're going to need to find that, because we want to find the total voltage. We're going to need the total current, which we have, the current entering the battery, and the total resistance of the circuit. So I'm going to write down R total here as well. So in order to get our EMF, we're going to have to use Ohm's law. First, let's find the total resistance. So let's solve that over here. R total is just going to be R1 plus R2, R1 plus R2, which is equal to 32 plus 12, 32 plus 12. And the units are kilo ohms. So that gives us a total resistance, R total, is equal to 44 kilo ohms. We have our total resistance. We can now find the EMF of our battery using Ohm's law for the whole circuit. So Ohm's law for the whole circuit says V total, or the EMF, is equal to I total, that's the current coming from the battery, times R total. All we're going to do is multiply I and R. We have 56 milliamps times 44 kilo ohms. We multiply those out, we'll get our answer. Now I'm going to use the fact that I know that milli is 10 to the minus 3 and kilo is 10 to the 3. So the milli and the kilo are actually going to cancel out when you multiply them together. So we just have to multiply 56 times 44, and we're going to be left with 2464, and an amp times an ohm is equal to a volt. So that's our V total. However, these each had 2 sig figs, so our final answer should have 2 sig figs as well. V total is equal to, it's going to be 2500 volts, or we could say 2.5 kilo volts. That is a lot of EMF. Woo! There's 3 little problems using series resistors.